Welcome. In this class, we'll start with NCERT Class 6 Chapter 2, that's Globe, understanding the globe, the longitudes and the latitudes. Now, we'll first start with the basic concept of latitude and longitude. We'll move forward with understanding time zones, calculating time zones and the concept of daylight saving. Now, to start with, when we talk about globe, let's take this ball as an example of globe, and you have a point here. The line which runs through this point would be the axis for this globe. Assuming this to be a globe, the topmost region would be the North Pole and the southmost region would be the South Pole. So we understand the basic terms when we talk about globe. It's the axis, North Pole and the South Pole. Now I can say globe is a representation of the real Earth on a small scale. So when we are trying to understand this, that helps us in drawing maps, projections, etc., which we will see further. Now, understanding the concept of latitudes and longitudes. Now, I can say this is a kind of sphere. That means it's 360 degrees. So, you have the time or the axis as 360 degrees, and around this 360 degrees, you have the 24 hours that are calculated. So when simplifying this, I can say 1 degree would be equal to 15 degrees would be equal to 1 hour. So you have 15 degrees as equal to 1 hour, and you would have 1 degree equivalent to 4 minutes. We will see how we use this as we move further. Now, when we come on to the basic concept of degrees, minutes and seconds, we have 1 degree which equals to 60 minutes, 1 minute which equals to 60 seconds. So that's the basic criteria we'll use as we move across in this lecture. Now, if I try to understand with the help of this ball, I can say the lines which are drawn horizontally would be the parallels. So we call these parallels also the latitudes. Now let's take the simple parallels in which this ball is divided. So you have one parallel that is running here, another two parallels running here. So there is a zone which is green, which is demarcated by the other two zones. So I can say this zone is the zone which is close to the 0 degree parallel, or the parallel that runs through the center of the earth, and this zone which runs north and south of the 0 degree, that's we call it as equator, is known as the torrid zone. So all this green would be the torrid zone. Now let's try to understand here in this diagram. So you have the 0 degree, which is the equator. North and south of equator, you have two major lines that are important both in the north hemisphere and the south hemisphere. So you have the equator, north of it 23 degrees in north, you have the Tropic of Cancer, and 23.5 degrees south you have Tropic of Capricorn. Then you have 66.5 degrees south the Antarctica Circle, and in the north you have the Arctic Circle. Now the region between Tropic of Cancer and Tropic of Capricorn, that's 23 degrees north and south of equator, would be known as the torrid zone. The region between Tropic of Cancer and Arctic Circle in the north, and Capricorn and Antarctic Circle in the south, would be known as the temperate zone, since the temperature would be moderate. And finally, Arctic Circle to South Pole, that's 66.5 to 90 degrees, north and south, would be known as the frigid zones. So these are the cool zones. Now these zones are important to understand when we talk about in terms of the heat and the atmospheric circulations, which we have already covered in the classes on climatology. So if we try to divide Earth into various zones, you have three basic zones, that's the torrid zone, temperate zone and the frigid zone towards the poles. The lines that run parallel to the Earth, that's horizontally, are known as latitudes or parallels, and these run east to west. So these are some of the basic characteristics that we try to understand about latitudes. Also, when you have a latitude here, all the latitudes north of it would be known as north latitudes. All the latitudes south of it would be known as south latitude. The southmost region would be the south pole. The northmost region would be the north pole. Now, in a simple way, I rotate this ball and you can see you have a line that runs vertically north to south. So lines which run vertically north to south are known as longitudes. So you have lines running north-south direction and these are known as longitudes. Longitudes are also known as meridians. So as we see here, you can have 360 lines that cover this complete circle. So you have 1 degree line for 360 degrees. So 1 degree will include 4 minutes. So you would have 4 minutes for 360 degrees. So if we calculate that, as we saw in the previous calculations, you would have 24 hours. And we say one rotation is completed in 24 hours. So you have the longitudes, I repeat, which are known as meridians. They run north and south. The meridian which runs 0 degree is known as the prime meridian or the Greenwich meridian. It is taken as the standard reference point. Nowadays, this Greenwich meridian is called as UTC, that's the Coordinated Universal Time. And so if this is 0 degree, the line directly opposite to it, which is this one, would be 180 degrees, and this 180 degree line would be known as International Date Line. And why we call it date line is because as we move east or west from the date line, you have the day that changes. So if I say today is 4th of August, here it would be 5th of August. So you would have changes in the day as you cross the international date line. Not so the case with the Greenwich meridian. Okay. So understanding this, you have a simple diagram to explain here. Now I have some points which are given here. For a very simple explanation, if I want to seek, I can say point A and point B are on the same vertical line. Since they are on the same vertical line, point A and B are on the same longitude, because longitude run perpendicular. Again you would have C and D would have the same longitude. So A and B would have a common longitude, C and D would have a common longitude. However, now let's talk about the latitudes. So when we talk about latitude, A and E, so this one and this one are running on the same horizontal line. Since they are running on the same horizontal line, they would have same latitude, or they are on the same parallel. Longitudes, as we said, are also known as meridians and they run north to south. So all lines, all points which are on the same north-south point would have same longitude or same meridian. All the points which are on the same latitude, same parallel would be known as the points on the same latitude, and they run east to west. Now, whenever we talk about the horizontal lines, there are some basic things which are very important. As I said, our complete earth covers 360 degrees. So let's take this ball again. I start from this ball again. So you have, this is the axis point. So I take this here. This is the 0 degree and this whole would cover 360. So half of it would be 180 and half of it would be 180. Now this would be 180 east and this would be 180 west. So this whole region would be west and this whole region would be east first of all. Now when we talk about time zones, it's important to understand that in time zones you have this which occurs as the center of the time zone. So if I talk about 0 degree Greenwich meridian, it's the center reference point which runs from 7.5 degrees east and 7.5 degrees west. So the whole region 7.5 degrees east to 7.5 degrees west would have a common time, and that common time would be equalized, or I would say would be standardized at 0 degree, which is the reference point, and that reference point is known as Greenwich meridian. Now as we talked about the international date line, which is 180 degrees, and this separates two consecutive calendar days. Now this line has been bent. Now originally all the meridians that we talk about cross in a perfect meridian, and they do not have any bends except the international date line. Now the only reason there are bends in the international date line is attributed to accommodate the island nations and the small territories, so that there is a same time within the complete country and there is no different time within the same country. Again, there was the problem with international date line accommodating Samoa. So you had old international date line that crossed this region. Later on, this international date line was modified to accommodate Samoa Island, and it was this point on the globe. If we see, you would have the change in the international date line that took place. So this is about the basics of latitude and longitude. Now coming to the standard time zones, as I said, 360 degrees contribute to 24 hours. So you would have 15 degrees which would contribute to 1 hour. So every 15 degree meridian would be 1 hour. So I can also say 1 degree would be equivalent to 4 minutes. Now in India, the extension runs from 68 degrees east to 97 degrees east nearly. So the total time zone, the total time difference between say Dwarka in the west to Dibrugarh in the east would be around 1 hour and 54 minutes. However, in India we have standardized the complete time with a single time zone, that is 82.5 degrees east, and this 82.5 degrees east is ahead of Greenwich meridian by 5 hours 30 minutes. So in simple terms, if I say, if in London at Greenwich the local time is say 2 p.m, the time in India would be at the same moment would be plus 5:30 to 2, means in the 2 p.m. you would add 5 hours 30 minutes more. So the local time would be 7:30 p.m. So if there is a live match that is going on in London at 2 p.m, in India you would see it at 7:30 p.m. So that's to understand how we try to calculate the time zone difference with a very fundamental example. Now here is something that we will try to explain and elaborate on the concept of time zones. So what I have drawn here is the sheet for the time zone, and what I am trying to explain here is understanding the time zones with respect to two different concepts. One is, if I know a time in a particular time zone, I can find the time in another time zone. The next is, if I know the time in a particular time zone and I am having a flight of say 8 hours or 10 hours, and I have to calculate the time in the another part when I reach, I could do that. So there can be two types of calculations that could be involved here. Now first of all, the 0 degree is the Greenwich time that I have taken into consideration. Now east of the Greenwich would be 15 degrees for each line. So I have just skipped one by one and written the time. So it's 30 degrees east, then 45, 60 degrees, 90 degrees and so on till you reach 180 degrees. And again this 180 degree and this 180 degree is a common line, but since I am drawing it on paper, I am marking these two lines on both the edges. Now there are two things which we will try to understand when we will talk about time zone. Let's say at 30 degrees east, the local time is 2 p.m. I need to find out the local time at 90 degrees east. How can I do that? As I know, with every 15 degrees there is a difference of one time zone, and all that is towards the east would be addition or ahead, and all towards the west would be subtraction or loss of time. So if it is 2 p.m. here, at 45 degrees it would be 3 p.m, at 60 degrees it would be 4 p.m, at 75 degrees it would be 5 p.m, and at 90 degrees it would be 6 p.m. So if I know the time at 30 degrees east, which is 2 p.m, I can straightforwardly calculate the time at 90 degrees east, which would be 6 p.m. Now that's one way. The other way around would be, if I know the time here is say 5 p.m, and the time here would be 9 p.m. So what is the difference between the time zone? So when I am having such a question, I have to see whether the values are towards the east or the west. Since both the values is 30 degrees east and 90 degrees east, and you have one time as 5 p.m. and another time as 9 p.m, I'll simply do the subtraction of two times. That's minus. So 9 minus 5 would be 4. So the difference between the time zones would be 4 hours. Now, if I have another case which I take as, say, let's say 30 degrees west and 30 degrees east. Now I have the time which is 5 p.m. here. I am moving backwards. So it would be 4 p.m, 3 p.m, 2 p.m and 1 p.m. Okay. So if it is 5 p.m. at 30 degrees east, it would be 1 p.m. at 30 degrees west. So what I am doing here is, if I know the time zones, say let's say here the time zone is -2, because this is -1, this is -2, okay, and here it's +1 and +2, and here the time zone is +2. So what's the difference between the two time zones? Since it's crossing the Greenwich meridian, you would have to add these two values, and the time difference would again be 4 hours. We had the time difference here, which is 2 plus 3 plus 4 plus 5 and plus 6. Okay, so if we calculate that ways, you had the time zones here as +2 and +6, and the difference of 6 minus 2 would be 4 again. Okay, you can take the difference by the time itself or the time zones. I am doing it either way. So first example explains about the time. The second example explains about the time zone. So if you are using the time zones, you have say +2 time zone and +6 time zone, the difference would be 4 hours, and again here you have +2 time zone and -2 time zone, and the difference would be 4 hours again. Let's understand how. So if we run on a number line, let's say 0, I jump 1 and 2 here, and then 3, 4, 5 and 6. So if we work for a simple number line for say lower grade standard students, say 4th or 5th students, they can easily understand that from 2, if I am jumping onto 6, there is a difference of 4. Now moving on to including the negative number line in the same concept, what would happen? It would be as simple as that. I am having +2 time zone here and -2 time zone here. So this would be my total jump, and I can say it would be 1, 2, 3 and 4 again. So this is a simple way to understand. When you cross Greenwich, you have to add the difference between two time zones. However, if the values are on the same side of Greenwich, be it east or be it west, you would have to subtract the time zones to find out the time difference. So that is one way of calculation. Now let's work around some examples that will help you better understand how we work around the time zones. So let's say you have an example where you have 120 degrees west, you have a time which is 4 p.m. So at 120 degrees west, you have 4 p.m. Now you have to find out the time at 90 degrees east. How can we do that? It's as simple as that. So as you move east, you are adding. So it would be 5 p.m., 6 p.m., 7 p.m., 8 p.m., 9 p.m., 10 p.m., 11 p.m., 12 noon. Okay. Then 12 noon, you would have a shift in the day. So if it is 4th June, it would become 5th June here. And then again 12, you would have 1, 2, 3, 4, 5 and 6. So it would be 6 a.m. here. So if the time is 4 p.m. at 20 degrees west, it would become 6 a.m. at 90 degrees east. So that's a kind of very simple calculation I did. Now let's complicate it a bit further. I'll include the flight time. Suppose I am boarding a flight from 120 degrees west. Again the same location. At the same time, say 4 p.m. My flight duration is 6 hours. At what time I will reach 0 degrees? That's London or the Greenwich meridian. Now how do I calculate this? I am starting at 4 p.m. My flight time is 6 hours. That means that 6 hours are lost in the air. So you would have the starting point as 10 p.m. Now when I move till 0 degrees, what would be the time? It would be 10 p.m., 11 p.m., 12, midnight, then 1 a.m., 2 a.m., 3 a.m., 4 a.m., 5 a.m. and 6 a.m. So I will reach 0 degrees London at 6 a.m. So if I am boarding today, I will reach tomorrow at 6 a.m. So that's one concept that you need to understand. Now the next important concept is the concept of dateline. So when we talk about dateline, it's important to understand how we move around the dateline. So when we move around the west of the to the west of the dateline and to the east of the dateline, there is a difference. So let's say I start with 105 degrees west and you have 5 p.m. So you have 105 degrees, 5 p.m. is the local time here. Okay, and the date is say 8th August. Now what would happen? Now let's calculate what would happen when I cross it towards the west, and then we will see what would happen when we cross it towards the east. Now this is the international dateline, and again this is the same international dateline. We are drawing it at two different locations and we will see how it works around when we cross the international dateline. Now when I am crossing the international dateline, I am starting with 5 p.m. It becomes 4 p.m. I am going back. So as I am moving west, I am losing time. So you have 5 p.m., 4 p.m., 3 p.m., 2 p.m., 1 p.m. and 12 noon. So at 180 degrees dateline, it's 12 noon. Now try to understand, as I said, we are taking this as a range between 7.5 degrees east and 7.5 degrees west, and this whole region would be 0 degrees or 0 time zone, and then you would have the next time zone which would start from here to here, that would be +1. Okay, so here again till this point it would be 12 noon, and since the day here is 8th August, what would happen? As soon as I will cross this, the half of the section here, it would be 12 noon, and as soon as I will cross beyond it, it would become 9th August. So you would have a day that would be added as I move there. Because let's move this way and then you will understand why we are adjusting the days and why it is important to adjust the days at international dateline. Now, the same example, let's go east. So I have 5 p.m., 6 p.m., 7 p.m., 8 p.m., 9 p.m., 10 p.m., 11 p.m. and 12 midnight. At 12 midnight, it automatically changes the day. So 8th August would here become 9th August. Now I am on 9th August. Okay, this region was 9th of August. This region is again 9th of August. It's 12 midnight. Now I am going further east, so it would be adding few more hours. So 1 am, 2 am, 3 am, 4 am, 5 am, 6 am, 7, 8, 9, 10, 11 and 12 am, 12 noon. And now this 12 noon, till the point I reach here, it would be 9th of August of 12th noon. But as soon as I cross the international date line towards the east, I lose a day. That means beyond 180 degrees east, it becomes 8th of August. And that is true because we can see here it was 8th of August. Since I am talking about the globe, now let's develop a perspective on the globe itself. So you have 180 degrees. Let's say this is 180 degrees and this is 0 degrees. I am starting from the back. I am starting somewhere here, which is 5 p.m. and I am trying to go east. So it's 105 degrees west, which is here, somewhere here, and I am trying to cross the date line towards the east. So this is 8th of August. I reach the meridian and I make it 9th of August, and as soon as I reach on the other side, it should again, when I cross it, become 8th of August, so as to maintain a common date on the globe. Otherwise, there would be no end to the expansion of the dates that we do. So it's important to understand that since we are on one globe, there should be a common time that should happen, and that can only happen if you have, say, this point, which is 180 degrees. If I cross it towards east, I lose a day. If I cross this towards west, I gain a day. That means if I am on 9th of August on this side, as soon as I cross the date line, it becomes 8th of August, and this whole region would remain 8th of August till the midnight when I reach the Greenwich, and there is a change in time, so it would become 9th of August. So in simple terms, I can say half would be 8th of August and half would be 9th of August, and when it will rotate, it would shift. So that's the basic idea which we try to explain or understand here. Now the next thing that is very important is the time zones that are spread across the country. Now if we just talk about the mainland itself, Russia has the maximum number of time zones with 11 time zones. However, if we talk about the mainland and its territories across the globe, you would have France that tops the list, and France has 12 time zones because of the territories that are spread throughout the world. So you have the main France, which is UTC 1, then you have the territories of French Polynesia here, you have the territories of French and Southern Level Islands in south of Africa, and then towards the Micronesia and Melanesian island groups. So all these together, if we talk about the expansion of French territories, France have total 12 time zones. However, if we talk about the mainland, the maximum number of time zones are visible in Russia with 11 time zones. Now there is another important concept that you must understand while you are trying to understand the concepts of latitude, longitude and time zones. The concept is daylight saving time. Now daylight saving time is also known as a summer time, and when we try to understand summer time in simple terms, it is setting a clock 1 hour ahead so as to save the daylight. So it's mainly common towards the polar regions, not the equatorial belt. Towards the polar region, what happens is you would have longer days during summers and shorter days during winters. So to absorb more and more sunlight for the longer day, what is the best idea is to increase the daytime. So you set your clocks 1 hour ahead, and you can take the maximum advantage of the natural light that is coming in. This would reduce the burden of the artificial sunlight. Now this concept was first introduced at Thunder Bay in Ontario in Canada in 1908. However, it was most popularly said that this concept came into origin with Germany in 1916, and in 2016 we are celebrating a century of daylight saving time. Now the countries which are marked in orange are the countries of the northern hemisphere that follow daylight saving time. The countries marked in blue are the countries of south hemisphere that follow daylight saving time. The countries which are lighter grey in color never ever had a daylight saving time. However, the countries which are marked in dark grey color, at some point of time they used daylight saving, but now they are not using the concept of daylight saving. So it's not a kind of very popular concept. It usually starts in around March and April and ends from somewhere between September to November. The basic idea is you are setting your clocks forward during the spring. As a result, the daylight saving time starts early and you lose 1 hour. However, during the fall, you set your clocks 1 hour behind and you regain 1 hour. So it's a concept that is used mainly by the polar countries to absorb more and more daylight and daylight time and the sunlight during the summers when they have longer summer days. So this was a basic idea to introduce you to the concept of latitude and longitude. With this we cover the chapter 2 of NCERT Class 6. As I said, we are covering these topics in a bit detail as those given in the NCERT. So that they are more useful for your upcoming competitive examinations. We will be covering the remaining topics of NCERT in our further lectures. Those who are interested in NCERT series can definitely subscribe to our channel, and hope this would be helpful for you. Have a good day ahead.